Woohoo! Scientific method. All right. Today we're going to be talking about the scientific method. And really, when I think about the scientific method, it's really a way of thinking. Science is a way of thinking. It's not just memorizing facts. The best definition I have of the scientific method is right here. The scientific method is a systematic way of answering mind-blowing questions based on evidence. So I think a neat example is this one I heard on the radio the other day. Right here we have some rocks, and the rocks in the desert in Death Valley. And you can see right here the movement of how they're going. So you can see they're twisting and turning, and you see they've definitely moved. This one all the way from back there. But the weird thing is that no one knew how they moved. This one's really cool right here. You can see it goes right over there and all of a sudden takes this crazy 90-degree turn. They never knew how they did this, but they used the scientific method to figure out how. So what they did was that they put a GPS unit right on these rocks and they filmed them, and they found out that with the GPS unit on it, that when it rained and it cooled down and formed a thin ice layer on this desert, and there was a small breeze pushing that rock, the rocks actually moved. So really wild idea, really cool thing, and the scientific method made this possible. When did the scientific method start? Well, we have this guy named Aristotle right here, and he was a really smart person, but he didn't use the scientific method. What he thought was, he had this idea about different sized rocks. So say if you have small rock versus a ginormous rock. He thought that when you dropped these rocks, this rock right here, the bigger rock, would fall faster. He didn't use any evidence, he didn't do any experiments, but because he was so smart, everyone believed him. So there's a problem with that. This other guy, named Galileo, he was an Italian. Oops, and I skipped ahead by mistake. He used the scientific method quite a lot, and he did the same experiment, or he thought of the same thing, but he did an experiment for it. So what he did was he made a wedge, like so, and he put different spheres on the wedge. And then he let them go down, and he timed them. He used a big one and then a small one. What he found out was that no, the big one didn't go faster. They both dropped the same rate. And it was because of his experiment, because of the scientific method, he was able to figure this out. So, let's go through the steps. First thing with the scientific method, you have to have a question. You have to be really curious about the world and observe things. So, you might have a question about, let's say, plants. So, let's say I draw this beautiful plant right here in a pot of soil. And we have a nice flower like that. And let's say we test the effect of music on the plant. You could do country, you could do rock, all these different things. And let's say my hypothesis, which is an educated guess based on prior knowledge. Let's say my hypothesis is that this plant right here is going to grow faster when it listens or when electric dance music is playing EDM because it has a faster tempo. Kind of a crazy idea, but who knows? All right. Once I have that idea and that hypothesis, I have to set up a controlled experiment. A controlled experiment, the best definition and the most important thing to know is that a controlled experiment only changes one variable at a time. So one variable changes. And there's different ways to break down variables, so this can get confusing for a lot of students. The independent variable is the thing that you actually changed in your experiment. So in this experiment, we're changing the types of music being played. So for our experiment, the independent variable would be types of music. The dependent variable is the thing that will change as a result of changing the independent variable. So if we change the type of music, say we change it from electric dance music to country, or say if it grows more when it listens to EDM, that growth rate would be the dependent variable. So, and again, independent variable is the thing that one thing that you change in the controlled experiment, and the dependent variable is the thing that changes as a result of changing the independent variable. Right here, controlled variables is everything else has to stay the same. So if we're, doing this experiment with flowers and plants, we have to water them the same. We have to control the amount of water they get. Everything has to have the same amount of water. Everything has to have the same amount of sun. And so on. So you got to keep everything else the same. This last one right here, this is really important. The control group is you need to compare whether music in general has an effect at all. So you have to have a group of plants, in this example, that aren't listening to any music. So our control group for this idea would be no music. And this is important because it's used as a method of comparison. So method of comparison. Okay. Onward. With our plant experiment, any scientific experiment, controlled experiment, you're going to have to collect data. So that's really important. You're putting graphs and charts and things like that. After that, once you collect that data, you're going to have to make inferences, and this is an important vocab word. Inferences is, making conclusions based on the data that you have and trying to, figure out what's going on here. So you're going to make inferences and conclusions from this data right here. So, say that I find out, and most likely that there's no effect of EDM or country music or rock music from looking at the data. I'm going to make an inference and a conclusion showing that, there's no effect on music and plants. After that, I'll publish my results. That's really important. Other people retest those results to see if my results are correct. And this is an interesting one, a theory. A lot of people don't know what a theory is, and it can be confusing. But basically what a theory is when you have so many people doing this experiment over and over again, and they're finding the same result and the same result again and again, then it will eventually become a theory. So really, a theory is, when you test something so many times that there's a general consensus that it's true from the scientific community. Okay. I think the biggest thing you want to get from this is be curious, like Curious George. That's the most important thing with the scientific method, and the scientific method in science is a way of thinking and a way of understanding.